logarithmic expression. Every operation has exactly one inverse or opposite. You started learning about that when you started solving equations. If you have a problem that is like x the opposite and you subtract 3. Those are inverses of each other. They're opposites. And so let's say we have an addition problem. What operation would you do to solve this problem? If you were solving for x, you would minus, subtract. So the opposite or the inverse of addition is subtraction. Minus 3, you would do the opposite and would add. What is the opposite of multiplication? Division, right? So if you were solving this one, you would divide. Alright, if you have x to some power, like you're cubing x, how would you solve for x? Cube root, yep. Or if it was x to the 4th, you do the 4th root, or x squared, you do the square root. But something that we've gotten into lately are exponentials, where x is in the exponent. That's the one we don't know how to solve for x. And so that's what we're going to get into. So when you have an exponential, meaning your variable is in the exponent, we can rewrite them into a different form. And rewriting them in this new form helps us to solve the equation. And that form is called they're called logarithms, but it's logarithmic form. So logarithmic. I will form logs. They look very different. So having 3 to the x, when I rewrite it in log form, they don't look anything alike, but they mean the same thing. You have 4 quarters, you have a dollar bill. Very, very different, but they are equivalent. Same thing, 0.5 and 1/2 don't even have the same numbers. One has a decimal, one's a fraction. Very different, they mean the same thing. So I'm going to kind of show you, like in general with all letters, it gets easier as we start putting numbers in. But if you have b to the a power equals c, so something to some power equals something, you can rewrite it. You write log, and logs have a base, which is, in this case, would be b, the number, the big number. Log base of c equals a. So let me show you an example. If I have 5 to the x equals 75. This is an equation, or I should have just done this one, 3 to the x equals 7. To solve this, we would have to convert it to log form. And so you write log, and then you have a base. The order of the numbers, it helps to maybe like draw this little swirl. Log first, then 75 x. So log equals x. And that's something you could actually type in your calculator right here. Okay. But that way you could solve to get x. So 5 to some power is 75. We could figure that out by using logs. So you always have log, and then this number of that equals that. So it's like a little backward swirl. That just tells you the order that you write these numbers in. Here's a couple of things that you need to know. Number one, if the base of a log, so like right here, so we say log base some number, that's how we read it. Log base 2, log base 3. If that base is 10, kind of just the general one. We normally don't put that 10 as your log with an X, and there's no little number down there. You can assume that little number is a 10. Kind of like when you see an X, you assume that there's a 1 in front of it, but we don't write it. Okay. And another one, if the base is E. Remember a while back, E is just a number like pi. It's 2 point something. So if your log is E, that's what we call the natural log, and you'll see it written like this, ln(x). That's the same thing as having log base E of x. That's called the natural log, and we will see that a lot. But the natural log has a base of E. What we're going to do right now is practice converting some of these from exponential to log. So we're just going to rewrite them. Okay. Now if you think about the swirl, you need to have like the exponent part on the left. Okay. And so this would be log. So the 3 comes first, then the 9 equals 2. So log base 3 of 9 equals 2. So the 3 is a little bitty kind of down. It's a subscript. It's down in the bottom corner. Log base 3 of 9 equals 2. So that's just rewriting them. So number 2, think about this swirl. Okay. So it would be log base 10 of y equals x. So the 10, then the y, then the x. However, if the base is 10, you're probably going to see that, like this. If it was multiple choice, you would not see the little 10. So it should be log of y. We don't say base 10. So it's log. I mean, it's not wrong. It's kind of like saying 1x versus x. You're not wrong if you say 1x, but you learn later on that people don't normally say 1x. So we would just read this log of y. So we just kind of drop base 10. We don't say log base 10 of y. Log of y equals x. All right. So number 3 would be log base r of w equals t. People will put these in parentheses. So you might see that, you might not. Now number 4, notice the part that has the exponent is not on the left. So if you try to do the little swirl, it's not going to work right. So I'm just going to flip that. E to the 3x equals y. Okay. So I would have log base e of y equals 3x. What is log base e? Natural log. So ln natural log of y equals 3x. So multiple choice, you would not see log base e. You won't see it written like that ever. I mean, 98% of the time. You'll see it written as ln natural log. I always do that in cursive. A cursive L. That's just what that is. That's just my habit. Okay. So now we're going to do the same thing, but we're going to go backwards. And the swirl still works. You just kind of ignore the log. 7 squared equals x. For the swirl to work, you need the log on the left. So I need to fix this one to say log base 3 of y equals x to do the swirl. So this is the same thing as having 3 to the x power equals y. Number 7, when you write it in exponential form, so you write it with, there's an exponent kind of, you need to know that 10 is there, because that's part of your exponential form. 10 squared equals y. So like I might give you number 7 and say, what is y? Well, in that form, you can't solve that. But if you convert it to exponential, what is y? Which is 100. Yeah. So you could solve that for y if you converted it. So you might have to solve an equation, and you would have to know, if you saw that, you're like, you can't divide both sides by log. Like, that's not a thing. It's kind of like trying to divide both sides by a division symbol. That doesn't make sense. You have to convert it to the other form. Sometimes you might try that and it might not work, but that's a tool that you have to know how to solve those equations. Okay. Number 8, natural log of c equals 4. Well, that's really log base e of c equals 4. So remember, natural log is log base e. And that would be e to the 4th power equals c. And so if I wanted you to actually solve for c and give me an answer, you can type in e to the 4th. This would be a calculator question. You've got that ln is the natural log button. If you hit that. Okay. Or if I took the natural log of this number, notice I get 4. Guess you can't notice because. Now down here it says evaluate without a calculator. Okay. So you could type this in the calculator. There is a way to type log base 2 of 8, hit enter, and you get an answer. But we're going to do these without a calculator. So I'm just going to say equals x. Okay. I'm going to call my answer x. And so I need to rewrite this in exponential form to figure out what x is. So this would be 2 to the x equals 8. So 2 to what power gives me 8. 2 times 2 is 4, times 2 is 8, so 3. So x equals 3. So we can call this x. If you want to go just put x, you can on all those. And if I just typed log base 2 of 8, hit enter in the calculator, it would give me 3. Alright, so number 10 would be 5 to the x equals 25. What is x? 2. Yep, because 5 squared is 25. Two to the x equals 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. How many times did I have? 5. So x is 5. Remember, if you don't see a base, a little number, it's 10. To the x equals 100. What is x? 2. Number 13. 16 to the x equals 4. Does anybody know what that one would be? We talked about it a while back. It's 1/2. Having a 1/2 power is the same thing as the square root. A 1/3 power is the same as the cubed root. A 1/4 power is the same as the fourth root. And so I know that the square root of 16 is 4. So that's why it's a 1/2 power. Alright, 14. 3 to the x equals 1. Any ideas of what exponent gives you 1? It's not. If you did 1/3, that would be the same thing as doing the cubed root of 3, which is not the same as dividing by 3. The cubed root of 3 is that. It's 0. Anything to the 0 power is 1. So my base could have been anything, and my answer would have been 0. This is log base 10 of 10 equals x. So 10 to the x equals 10. What's x? 1. Yep. And then the last one of these, 6 to the x equals 1/36. Negative 2. that moves it to the bottom. So 6 to the positive 2 is 30. I have 2 to the third power, that's 8. Negative third is 1 over 8. And it works here like this. 1 over 4, I would have had a negative 1/2. So you number 17 through 20. So I'm going to show you how to get these. If you see right here by the 7, you see log. That, if you use this button, it's log base 10. So I can use that on number 17. And I can do log of 9. .954. So that's saying that 10 to that power is 9, basically. 8.9999. So 18, same thing. Log of 625. 2.79588. But number 19, you can't do that. So a couple places to find this in the calculator. Alpha window. If you look down at number 5, it says log base. It's going to let you type in a different base. That's probably the easiest place to find it. So log base 2 of 10. So number 20, log base 7 of 135 is 2.520813. So that means 7 to this power is basically 135. So I'll let you type in a different base. If you use the log button, that's base 10. We're going to talk a little bit, just briefly, about some special graphs. So when you have logs, I'm not going to read all of this out, but notice this graph. This is the graph of a log. There's a lot of points that are like really close to the x-axis. They're technically not on it, but it's this number. This is such a big number. There's such a wide range there, basically. It's really hard to tell what those points would be. So types by the same number every time. Like it's 10, which is like 10. 10 squared, 100. 10 cubed, 1,000. So the scale of your y-axis is different. You might see these on a multiple choice question, maybe 1 or 2, but they are really easy to get. So let's just skip down here to this bottom. This is what your graphs most likely will look like. It'll have all these lines. Your x-axis still goes up by 1. This first chunk, you're counting by ones. So 1, 2, 3, 4, and so on. Once you hit the 10, you're counting by tens. 10, 20, 30, 40, and so on. And then you're counting by hundreds. So if we're going to graph the point 1, 20 on this. We would go to 1. This first bold line here is 10. The next line up from that would be 20 because you're counting by tens. So it would be right there. So this would be like 10, 20, 30, 40, and they get closer together. So that's A. B, the X is 2, the Y is 300. So I'm going to go up here. This starts counting by 100. So this would be 100, 200, 300. C, 3, 2. Notice the very bottom line is not 0 like a normal coordinate plane, it's 1. So the x-axis is 1, the next line up is 2. D, we have 4, 15. So this bold line is 10, the next one is 20. So 15 is going to be between the two. And then E is 5, 350. So graph where you think that one would be. Right there. So this bold line is 100, 200, 300. The next one would be 400, so it's between 3 and 400. Those are questions. As long as you remember seeing this graph, it looks confusing, but those should be fairly easy questions. All right. So